Hey everybody, Jeff Oriama here. Welcome to Schema Workshop, where we design an API around a set of realistic requirements and constraints, trying something new each time. Okay, so let's get into the requirements. Streaming media catalog. I like it already. And let's start with the context. A streaming service answers questions about its catalog of movies and shows, what a title is about, where it can be watched, and in what quality from a single, shared implementation. That's a dirty word these days. Shared implementation. What? Anyway, 3 teams maintain that implementation. One owns the content metadata, name, synopsis, cast, and so on. One owns regional licensing rights, and one owns playback and device support. So right off the bat, right, like a lot of different domains sharing a home. Okay. These 3 teams have already decided to split their shared implementation into 3 independently owned and deployed services, 1 per team, so that each can ship changes on its own schedule without waiting on or being broken by the other 2. So like classic use case for federation, right? See this all the time. Teams share a graph, right? They want to create that unified service layer so that their different user experiences, their different deployed clients can go ahead and select what data they need from like this one representation of all the different data that their platform can expose, right? But at the same time, they have a ton of back-end teams that need, the sort of granularity and bounding that having like microservices provides. So what do? Well, that's where GraphQL Federation really comes in as a really compelling way to preserve both the bounded context of your team's domain, right? So that you own your own service, you maintain your own schema, but also the unified sort of like abstract graph that represents all of your business objects that's available for the client to select. So you get the best of both worlds. All right, let's get on to the ask. Give the client enough information to render a title detail page in a single request. Tell me everything about this piece of content. And I think, just reading this, we're going to have to cheat a little bit, right? Because right now, this is sort of a back-end change, so to speak. So we're going to write the dream query for this because it's going to represent the client experience today. And then we're going to find a way to take this one kind of monograph, so to speak, and turn it into a federated graph or a supergraph, if you will. So let's read on. For a given piece of content, a client must be able to determine all in one request its core details, name, synopsis, genre, cast, release year, and whether it's a movie or series, which regions it's currently licensed to stream in, and until when, and what playback quality and features it supports, resolutions, audio tracks, subtitles, and whether it's available for offline download. Okay, great. Straightforward there. And let's go ahead and get to the constraints. Always the sad part, right? No team service may embed or duplicate a field owned by another team's service. Again, Federation gives us the vocabulary for that. All 3 teams already identify a given piece of content using the same identifier. The design must make that shared identity explicit rather than leaving it as something the client has to infer. Fair enough. Client should not need to know or care which team service produced which piece of the answer. This is crucial, right? And this is what a lot of teams sometimes miss when they're new to Federation is like the entire idea to, as much as practically possible, is to make the schema, the supergraph schema, the unified schema, one abstract representation. If the clients need to start thinking about your backend architecture, that's a smell. Okay, and let's go on. Each team's service must be deployable independently of the others at any time without coordinating a shared release. Great. Adding a 4th team's data about the same piece of content later must not require any of the existing 3 services to change. Okay, so we got our work cut out for us. As usual, we're going to start with the dream query here. For those of you who might be new to schema design or this video series, we usually start every API design exercise with a thought about the client experience, the user experience, because that's who we're serving. We're serving the end user. That's what GraphQL is all about. It's about exposing this catalog of data in a really principled way so that we're able to go ahead and express the user need through this query artifact. So we're going to make a query that represents the client experience, and then we're going to go back and design our schema from there. And sometimes this is a dialectic. Now, this is a special exercise because what we're modeling is more of a service architecture schema exercise rather than like trying to find the best way to express our types. So there's some nuance here today. So the dream query we're not going to be returning to very much. I'd like to just write one that demonstrates the user need, and then we'll design the service around it. Okay, so we'll keep it simple. So according to the requirements, right, we need core details, regions, playback quality, features, etc. Right, so let's start writing that. We want an identifier, right? We need the name of the media item. So think like a movie, a TV show, episode, something like that. So it needs a name, obviously. Synopsis, we'll call it, for just, description. Imagine a genre would be helpful. I'm just thinking about my streaming viewing habits and what I look for. Release year. Content type. And content type is something I'm talking about like in terms of like a movie or a series. So I guess that would be like a TV show or something like that. We'll get more sharp about that. So licensing, this is a big one under the hood. We don't see it too much unless you're moving from country to country, so to speak, a lot. But this would be like, hey, what available regions are there and licensed until. And that was part of the requirements here, like, right? So you see that all the time sometimes, like, oh, this show is leaving, this show is arriving. Unfortunate reality of the way licensing works. And the last category is playback quality and features, like resolutions, etc. So let's go ahead and encode that. Let's say playback, call it that. And again, I'm thinking about how I'm rendering this in a UI, right? We don't need to have that blocked out in order to imagine it. Supported resolutions. That'll probably be an enum, right? Audio tracks. Subtitles. Offline download available for folks who like to do airplane viewing, right? Did we get everything? Resolutions, audio tracks, subtitles, and available for offline download. All right, cool. I think those are our requirements for our dream query, right? So now let's move to our schema. So as a recap, like we already have, we're gonna go ahead and get this into a federated service, but let's go ahead and model this in a schema just for the schema design part of this, and then we'll get into how we break up our monograph into a supergraph. Okay, so I've already subbed out a root query with a media item, right? And it occurs to me too that in our dream query, I left out the actual media item. So we have to pass that ID and nest all this within that. Okay, cool. All right, now a dream query is a dream query. So we have our media item, right? And we've already stepped out the ID. So luckily we can pretty much do this pretty quickly because a lot of this is flat. So every media item needs to have a name. It's non-nullable, right? A movie or a TV show without a name wouldn't really be possible. So we're gonna make that non-null with the exclamation point. Synopsis. Hot take, this is nullable. Not sure exactly why you would post a TV series, but I think this is nullable. I think you can render something in a user interface and not need a synopsis. So let's keep that nullable. Same for genre. I don't think every publisher would necessarily want to fill in a genre. I could imagine a stubborn film director saying, my work transcends boundaries and genres. So let's keep that nullable. All right, let's get release year. That would be an integer. Sure, why not? A content type. And this will be an enum. We always have to have a content type. We need to know whether it's like a show or a movie, right? So let's just add an enum now. Let's make it a movie and we'll say series. How about that? It's more precise than TV show, isn't it? Let's stub these out. Licensing. And playback. And I imagine these should be non-nullable, right? For every piece of media and for every playback type, I think we need to know this, right? If we don't have this information, how can we possibly render a reliable user experience? So I'm going to go ahead and say these are non-nullable. Let's tackle licensing first. And I believe we have in our dream query available regions, licensed until. Available regions. Let's make this super simple. I mean, we could go down a rabbit hole here. And let's just make them a list of strings. I don't think null region would be possible. And I don't think we would ever have a null value for available regions. I don't think we'd ever have a null element in that list. So let's keep this a non-nullable list of non-nullable elements. And we'll say license until is a date, and I need to actually, that's not an out-of-the-box scalar, so let me go ahead and just postulate a date scalar. Should be simple enough. I could imagine for like, let's say I'm like a studio that has a streaming service, maybe licensed until could be nullable, because let's say I'm like Netflix, for example, I have my own studio, and it would be redundant to say something is licensed until a certain date because it's my property. So I'm going to go ahead and say that's a nullable entity. And let's go ahead and do playback now. And in our dream query, in our user experience, right, we have supported resolutions. I'm going to keep things simple here. I'm going to say that this is an enum as well. Resolution. So like we have to be able to support resolutions. So let's go ahead and add an enum of resolution. And let's do like standard definition, high definition, and ultra high definition 4K. How about that? Keep it simple. Can get to go down the whole 720p route and everything like that. Hot take, by the way, it's time. I don't know if we should call 720p HD anymore. All right, I'm getting off my high horse on that one. Let's move on. Audio tracks. Let's keep that string. I imagine that a stickler might want that to be like broken down by region, and maybe we could go down that modeling rabbit hole. But for simplicity's sake, let's keep it open-ended here. Same thing for subtitles. Again, we could add region strings and everything like that, go down the rabbit hole, but we'll call it a non-nullable list of strings. Now this would be interesting, actually. I had this as non-nullable, but I wonder if subtitles just were not available for whatever reason. That would make me sad. I'm going to say that this is a nullable field, but if it's there, then all of its members should be non-nullable. Okay, and then offline download available should be Boolean. I'll make it non-null just because it's a yes or no question. If there's missing data, null data, that's probably not what we want because then it's ambiguous. And I think that this is a pretty good point to say, okay, this is what our monograph schema would look like. If this were one service and everybody was happy sharing it, this is what it would look like. And I will say, when we're done breaking up this monograph into subgraphs and a supergraph, it will still look this way to the end user, right? We're still going to be satisfying the stream query. It's just that now our job shifts from designing the right schema to now figuring out which parts of the schema belong in which services, and that's its own adventure that we're going to go down. So let's go ahead and do that. The first step is, I mean, we don't want to boil the ocean, right? Let's do one thing at a time. So we're going to go ahead and peel off one of these business object domains into its own subgraph. And, you know, obviously this is a small enough schema that we can do this in one video, right? But if you or your team are thinking about how to break up your monograph into subgraphs, again, like one at a time is oftentimes a really good principle to live by. It reduces the surface area of problems. You can narrow down any issues with your DevOps, right, through deployment cycles, all that good stuff. And also just from a schema design principle, it's a lot easier to conceptualize, you know, the boundaries when you're moving one at a time. So let's start there. Our dream query really used the media item as the entry point. And so media item, I think, is really home base. So let's start a new schema called licensing, and we'll move the licensing bit over to that subgraph. Okay, so let's go ahead and call it licensing schema. GraphQL. Let's do that. Great. Let's go ahead and do licensing. And the first thing we're going to do to both of our schemas is to add federation directives. Got the @ so here we just do @ extend schema, @ link, and then we just give it a spec to follow. So I'm just going to go ahead and do that. I had this kind of already spring loaded here, and I'll do the same thing to the other schema here. Okay, great. So in our new schema that's reserved for licensing, let's just start there. So we'll take the type licensing from the old schema and put it in the new one. Okay? Great. Easy peasy, right? Now here's the interesting part. In our dream query, right, we still want to be able to access licensing from the media item entry point, right, in our root query. But in this, there's no way to do that, because now if we look back on our original schema file, we make this reference to a licensing type that we're no longer able to access, right? One key to understanding federation is that every schema should be valid in and of itself. Okay? That means I'm referring to this licensing type here, and yet there's no license in this graph. Okay? No licensing object. So I have to remove this. The good news is I can go ahead and add that over here, but I need to redeclare the media item type. Now that might seem counterintuitive at first, because I'm essentially duplicating my logic, but it really doesn't work that way. So let's go ahead and refer to that field. And I just realized I did an uppercase P instead of a lowercase p here, so got to fix that. And we're going to go ahead and declare the ID field. And this is going to be important later on, because the glue that holds these two entities together is this directive that we're importing called key. Okay? And we need to add that in both places now, because this one notion of an object, media item, is now being referred to in two subgraphs. Okay? And we're going to go ahead and give it fields ID. And what that does is guarantees that when we're looking up media item, if we're accessing it, these two subgraphs can add members to that object and treat them as the same. And the unifying thing, the lookup that they're looking at, you could look at it like a foreign key relationship, but that's like not exactly true, because it's actually the same thing. Basically, they're just referring to the same object, but contributing different fields to it. So you could see here, the media item type is declared here and has certain fields, and it's declared there and has certain fields. And the fields that are in common are the ones that identify them. So now what we've effectively done is added a service boundary in between this. Now, in Apollo Federation and in other Federation implementations, you also need to make sure that you update the resolvers in each of these. Now, I have a toy resolver, and normally in the Schema Workshop videos, I don't go into resolver logic because it kind of gets in the way of the notion of schema design. But for this, I will make an exception. So I'm going to go ahead and take a look at the licensing server, for example, and I want to just show you what changes you'd be making. And it's this resolve reference bit. Let me go ahead and open this in a bigger window. So now in this subgraph, we have this media item resolver, and we have to add this meta field __ or dunder resolve reference. We pass it and we have a parameter, the reference, that's the actual object that's being fetched, in this case from mocks, but it could be a database call or whatever. And then we're pulling out the ID of that. And what that does is provides at execution time the actual value that's needed in order to unify these two objects. I won't go into greater detail than that, but there are wonderful courses on Apollo Odyssey where you can look up the details and the inner workings of federation and how it works. But I wanted to mention that because it's not just as simple as adding a directive to your schema. Now, when lookup is implemented, that'll be a different thing altogether. But if that doesn't mean anything to you, then that's fine. We can escape right past it. But improved APIs are coming in the future. So anyhow, this is our first stab, and I just realized we refer to date here, so we do need to declare that scalar date. And we can actually remove it here because it's no longer being referred to in this subgraph. Okay, so we have successfully changed our monograph now into a supergraph. So this is what it looks like when you are doing schema design over multiple graphs that are all are contributing to the same object. We call that an entity, and it's sort of the foundational concept of how to do federation. So let's tackle now our third subgraph. We're going to give it the same kind of treatment here. So let's go ahead and make our new file. And this time we'll call it, so we had our licensing schema, and we have our original schema, and we'll call this, we'll move out playback next. So we'll call it playback schema.graphql. Great. And let's enter that. So again, we know this is a federated schema, so we need to import the federation directives that we need. We're going to be using key for this. Okay. So for playback, we know we need the type playback, right? And let's actually go ahead and grab it from our original schema and place it right there. Okay. Now a few things come into play here. First of all, we are referring to the resolution type, which is currently in another GraphQL file. This will not be valid until we actually are placing this where it is referred to. Okay. And that's set. Now, again, we're going to follow the same pattern. In the media item object, in the original schema, we are referring to this playback type through the root field playback. We can no longer do that, right? Because playback as an object is in a different schema. So let's go ahead and re-implement media item here with just the types that are available in this subgraph. So we're going to remove all this stuff and just refer to playback. Now all of a sudden, we have separated all of our business types into separate services with separate schemas that all combine into a unified representation. And we'll see that in action in just a moment. But this is the power of federation, where you can use this @key directive to define your entities so that they can all be referred to by a common identifier. And because of that, you're able to go ahead and place fields heterogeneously from different entry points without compromising the integrity of the object and without compromising the integrity of your service boundaries. This is big. Now I know this is a small schema workshop, a bit of a toy problem, but you imagine this at scale, right? You imagine all the teams in your workplace that are working in microservices, right? But you also imagine all the client experiences that need a coherent graph that spans services. Are you going to leave all those clients to orchestrate all those API calls themselves, to do a bunch of fetches and waterfalls in a row? Or are you going to make, an endless series of backends for front ends? Or are you going to go ahead and compose one graph that handles all the deduplication, all of the common identifiers themselves, and is statically analyzable and will fail at build time if you try to do anything silly. I mean, that's huge. One thing's remaining here. I now have to remove the playback type from the original schema, and because I'm a completionist, I want to make sure that we're actually renaming this properly. So this is no longer just our root schema. It's our, we'll call it media item schema. How about that? Sound good? Great. So we'll make that the graph. Oh, I think I put that in the wrong pane. Hang on. Okay, media item. Yep, there we go. So now we have 3 well-defined schemas to choose from. So before we declare victory and show the result in Explorer and Sandbox, let's just double check, right? Give a client enough information to do all this stuff. Well, we verified that in the beginning. No team service may embed or duplicate a field owned by another team's service. This is broadly true. Just because you're identifying the media item object by its ID in multiple subgraphs does not mean you're duplicating it. You are not redefining it. All you're doing is referring to a common field that identifies it. So I want to make that distinction clear. Shared identity explicit. That's at key in a nutshell. Which team service produced which piece of the answer? We'll see that in a moment, but yes, the answer is yes, we did that, and I will show you. Each team service must be deployable independently of the others at any time. Yes, so each of those schemas are backed by its own service, period. Adding a 4th team's data. So you can imagine another subgraph that we add here. So right now we have catalog, we have playback, we have licensing, maybe we have a database of actors, cast, whatever you have. I almost started writing a cast field earlier and putting actors in there. Like, you can imagine how adding new fields and having them being able to access at different points of the graph scales infinitely well here. All right, so I'm opening up localhost here, and what's running here is Apollo router, but this will work for any Federation runtime. This is the result of the different subgraphs being composed into a supergraph, and this is the resulting schema. You can see our enums here, right? Resolution, content type. Our query has the media item root field, and notice media item is only declared once. And all of the different at key directives show that we are now composing all of these together. So all those fields, even though we're defining them across 3 different schemas, are all unified together into one entry point. You can see it in the visualization too. So, well, I like showing enum types. So, yeah. So you can see here our query. We can get that media item. It'll give us all of our types. You can even see licensing pointing over to the licensing type, playback over to the playback type, and then all of our enums there as well. And to see this working end to end, I've wired up just some stub data in the resolvers, but I've loaded that dream query here into our IDE, and all we have to do is execute it and check it out. Got this movie glass houses, and all the expected data is right here at our fingertips. So what did we just see? Well, it's a challenge that a lot of teams operating GraphQL at scale are contending with, which is, what do I do when I've outgrown my monograph? Or what do I do when I want to break my services up into microservices, but still keep the benefits of a single schema servicing all of our client types, all of our user experiences? And what we just did is an example of that in action, how we can take an existing GraphQL service, start moving out box by box, type by type, into defined service boundaries that might match our org chart, and then using the at-key directive, and there's more to federation than at-key, but at-key is a foundational concept in order to define our entities that span multiple subgraphs and be able to contribute to them independently, but also in a coherent and composable manner. Now, I know this is a little bit of a different video than most of our schema workshops so far, but I think it's a worthy pursuit. A lot of folks ask me, Jeff, what should we be thinking about when we start with, we're starting with a monograph and we want to get into federation? Well, here's an example of how that could go for you and your team. A simplified example, but an example nonetheless. Find that low-hanging fruit, find your org chart boundaries, find your service boundaries, and start moving your schema bit by bit into there. Don't jump into the deep end of federation right away. Instead, start with the concept of entities with at key and work outward from there. I hope that was helpful. Let me know what you think in the comments, of course. Don't forget to subscribe for more Schema Workshop videos. That's it for now. See you next time.